Hello everybody, we're into chapter 2 of the Purple Book test review. So hopefully this will be good for you, hopefully this will help, so let's go ahead and get started. There's not a whole lot in this one, luckily, there's just a few different concepts for us. So we're going to be looking at how do we multiply, divide, add, and subtract in scientific notation. So let's go ahead and get this started. We need to first pretend that our scientific notation, our exponents here, our 10 to the fourth and 10 to the squared, are just variables. So this would mean like 3a to the fourth times 4a squared. So we need to treat them the same exact way. But let's go ahead and see how things work. So first I'll multiply my numbers. The 3 and the 4 gives me a 12. Now I multiply my 10s to their base, and I have a 10 to the fourth and a 10 squared. And as we've learned earlier in this year, in the last chapter, that when we multiply exponents, we add them. So 10 to the fourth and 10 squared is 10 to the sixth. Okay, now I can't ever have a scientific notation with more than one number to the left of the decimal. And 12 is two numbers, because if I put 12, I put a decimal there. There's two numbers to the left. So I'll go ahead and I'll put that over here. That becomes 1.2. Well, now I have to come back one more number than I was before. So my 10 to the sixth becomes 10 to the seventh. Let's go ahead and continue on through here. We're going to continue with multiplication. So here I have to be careful with my decimals. So let's go ahead and we're going to do the same thing and multiply our numbers. So I'll go 3.5 times 2.1. We'll go ahead and do this when we have a 5. We have a 3. Drop down our 0. 2 times 5 is 10. Put a 1 up here. 2 times 3 is 6. And 1 more is 7. So when I look at this, I should have 735. Now I've got to take close attention to multiplying decimals. And I notice I have one decimal there and one decimal here to give me two decimal spots. So I end up with 7.35. Now I can go ahead and look at my tens. I have a 10 to the third and a 10 to the fifth. And as we just talked about, when we multiply exponents, we add. So that becomes 3 plus 5 is 8, so 10 to the eighth. Okay, now we have negative, sorry, I got a little tongue-tied, but we have negative exponents. Let's go ahead and see how those work. Same exact thing. I'll multiply my 2 times 3 to get 6. And now what we said just a second ago, when I multiply exponents, I add them. Well, negative 2 plus negative 7. Well, that's negative 2 and a negative 7 combining. So I should know that's to the negative 9. So 6 times 10 to the negative 9. We know that will be a very, very small number. It would be 6 with 8 decimal points, 8 zeros before it, before we get to that decimal point. So it would be 0.8 zeros and a 6 if I was to write that out. Okay, now we're going to continue with the negative. I have a 3 times 5, which is 15. And then I'm going to go 10 to the negative 5 times 10 to the negative third is 10 to the negative 8. Well, once again, I cannot have this with more than 1 to the left. So 15 becomes 1.5 because I moved that over 1. Which way do I make this? Well, I've already gone backwards 1 of the 8 it's telling me. So I've already gone back 1 of the 8 it's telling me. So now I only have to go back. The negatives go back 7. So it's 1.5 times 10 to the negative 7. Okay, when we divide scientific notation, it's the same as we did when we were dividing exponents. So first we deal with the numbers, then we deal with the exponents. And in division of exponents, it is subtraction. So first we'll look at 6 divided by 3. Well, let's just act like it's any other fraction. They're both divisible by 3, so this becomes a 1. And the 6, well, that becomes a 2. Let's look at our exponents now. If I'm going to subtract, then 10 to the fourth is bigger than 10 squared. 10 to the fourth is bigger than 10 squared. So I'll subtract 2 from 4. And the 2 becomes a 2 up here. And my final answer now, there's nothing left on the bottom. I just have the number 1. So on top, what I'm left with is 2 times 10 squared. If I really wanted to see this in regular notation, then I would just say that's 2 with 2 zeros, or that's 200. Okay, let's divide another one. I have 12 divided by 3. Well, they're both divisible by 3. So I've got a 4 and a 1 now. As we talked about a second ago, when we divide exponents, we subtract. So I have a negative 2 up top, and I have a 4 on the bottom. Well, that is a negative 2. This x is a minus 4. So my final answer will be 4 times 10 to the negative 6th. If I'd like to see how this would look in standard notation, I would have my decimal point. And then I had to move this 6 spots. So that would be 5 more zeros. 1, 2, 3, 4, 5, with a 4 at the end. But this is the answer we want it written as, is 4 times 10 to the negative 6. And then when we add scientific notation and subtract, now it gets a little trickier. We have to make sure that our exponents match. Because if we remember back to variables, I can only combine like terms. So right now, 10 to the third is not a like term with 10 to the fourth. So I need to make them that way. So I'll always start with my bigger one. This is my bigger number. So I want to turn 10 to the third into a 10 to the fourth. Well, if I think about it, if I move the decimal spot from here to here, that would make it have to come back 4 spots instead. So it'd be 0.2 times 10 to the fourth. And this is plus 3 times 10 to the fourth. Well, now let's go ahead and combine these numbers. I've got a 0.2 and a 3, so we just put those together as 3.2 times 10 to the fourth. And we are completed. So remember, we're going to start with a bigger number. The bigger number was 3 times 10 to the fourth, so I need to turn them both into 10 to the fourths. All that was having to move the decimal point one more spot, and then I combine my numbers. Okay, so we'll do the same thing here, but nicely, they are both to the same exact exponent. So all I got to do is straight up subtract, and we're good. I'll go 3, and a minus 2 is a 1, times my base does not change, 10 to the negative third. Okay, if I was to write that out, just so we see, I'd take my 1 and I'd go over 3 spots, so that would give me 2 zeros before the 1. Okay, 6 times 10 to the negative fifth minus 3 times 10 to the negative third. So once again, I picked the bigger number. And if we think about this, it sometimes isn't intuitive, but my smaller negative exponent is bigger because they're closer to 0. The other one's going to have more zeros before the number. So I want to turn them both into a negative 3. So if I want this to go to a negative 3, right there, it's a negative 5. I moved it back 1, that's a negative 4. I moved it back another, it's a negative 3. So I'd be 0.06 times 10 to the negative third minus 3 times 10 to the negative third. Well, this gets tricky because 3 being my bigger number, okay, I got to go back to my rules for integers. And when the signs are different, I keep the sign of the larger. Well, and if we look, the larger number is here, keeping the sign as a negative. And I find the difference. Well, my difference will be now 3. We'll go 0.00 minus 0.06. And look at this, is 3 becomes a 2, a 9, a 10. So that's a 4. That's a 9. And I get negative 2.94. And then we know it's times 10 to the negative third. If we wanted to see this and how it works, we know we're moving our decimal point 3 spots. So I could say or negative 0.00294. All right, let's go ahead and go to our next one. Just a couple left, really. Now we're looking at our metrics. Every time I move one of these, so I'll start with my center numbers, my center words, I mean. So I have bytes, meters, liters, and grams. That's just standard units for metric. Every time I move one of these major categories, it is 1,000. So as we see, when we go from a byte to a kilobyte, I went up 1,000. So there's 1,000 bytes in a kilobyte. There's 1,000 kilobytes in a megabyte. There's 1,000 megabytes in a gigabyte. There's 1,000 gigabytes in a terabyte. So you can imagine a terabyte is really pretty big. But that goes for anything that would be meters, liters. It would be 1,000 megagrams in a gigagram. Okay, and it works the same way going down. We have 1,000 between each one of these measures. All the way down. So my smallest is a pico. And then there's 1,000 picos in a nano. There's 1,000 nanos in a micro. There's 1,000 micros in a milli. 1,000 millis in a byte, a meter, a liter, or a gram. There's 1,000 byte, meter, liter, grams in a kilo. 1,000 kilos in a mega. 1,000 megas in a giga. 1,000 gigas in a tera. We also see that there's 3 zeros. So that means each time we are just adding 3 more zeros. So this is plus 3, plus 3, plus 3, plus 3. Now, for instance, I'll say that I have 200 kilobytes. Well, I want to find out how many millibytes I have. So if I go back, I know there's 1,000 bytes in a kilo, so I would have 200 plus 3 more zeros. And that's how many bytes I have. Well, I want to find out how many millibytes, because that's what we said at first. That's 3 more zeros. So I've got my 5 zeros I have, and I'm going to add 3 more zeros to get to millibytes. If I want to put that in scientific notation, then that would be 2 times 10, and add the zeros. 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the 8th millibytes. Where this was 2 times 10 squared kilobytes, and this is 2 times 10 to the 5th megabytes. Oh, sorry, I said that wrong. Bytes. Now, all three of those are equivalent numbers. 2 times 10 squared kilobytes, 2 times 10 to the 5th bytes, and 2 times 10 to the 8th millibytes. And one last thing, we're going to do a word problem with these. And so we see that the Stockholm Globe Arena resembles a hemisphere. Now, if we think about what a hemisphere is, that'll be important, so I want you guys to think about what that is for a sec while I finish reading this. But it has an inner diameter of about 1.1 times 10 squared. And I say about because if it's in scientific notation, it has been rounded, but we will work with the numbers they've given us. It says find the approximate volume, once again, approximate because we are not sure of the exact, of the building. Use 3.14 for pi. Well, the number one thing, like I tell you with so many of these, is we need to know our formulas. So let's go ahead what we figured out. If we're dealing with a hemisphere, that's right, that is half of a sphere. So first thing is we need to know what the area, what the volume of a sphere is. Okay, because they are asking you for the volume. So we should have 4 thirds pi r cubed. Okay, they say it's a half of it. So times 1/2. So that would be 2 thirds pi r cubed. And now we use the numbers we know. And it says that the radius, well, it says the diameter is 1.1 times 10 squared. So then I need to take 1.1 times 10 squared. If that is the diameter, I need the radius. So to go from diameter to radius, I cut it in half. So that would be 0.55 times 10 squared. Well, that's not going to work very well, so let's go ahead and move over our 2 decimal points, and I see that is 55. Okay, so I have 2 thirds of times 3.14 times 55. The way that I'll usually ask you to do it is just keep it in pi. If we kept this in pi instead, I would see that I have 110 thirds pi, and that could be my final answer. But I would have to say meters cubed. If I want to do this out all the way, then I would have to go and do 2 thirds times 3.14 times 55. I'll let you go ahead and do that instead of wasting the time on the board right here. And you see that we are completed with this. So thank you. Hope this helps. Good luck.